Hello gentlemen, how are we doing today? I'm going to give the instructional and lecture video for you for April the 14th. And it's going to be relating to underground fault indicators, which you've seen. I've got some more videos out there on YouTube for it. And these are the instructions as far as getting you guys through the quiz. Okay. So, firstly, a fault indicator is a device which provides visual or remote indication of a fault on an electric power system, also called a faulted circuit indicator, FCI. The device is used in electrical power distribution networks as a means of automatically detecting and identifying faults to reduce outage time. Overhead indicators are used to visualize the occurrence of an electrical fault on an overhead electrical system. Underground indicators locate faults in an underground system. Often these devices are located in an underground vault. Some vault indicators communicate back to central locations using radio or cellular signals. I will let you know, they just give the vault example here in this situation. Santee Cooper is very proactive of using fault indicators, and we're going to stick to the underground side of using fault indicators. And they have them in, of course, vaults, three-phase enclosures, transformers, both three-phase and single-phase, and sometimes even in switch gears. So they are very widely used, and they are a great tool as far as the industry is concerned in finding faults in your underground system. If you remember yesterday, well, April the 13th, that instruction was we were having to go out and from the dip pole high pot every single span until we came to the point where we found the bad and faulted cable. Fault indicators will do that for you. They're not going to high pot it, but they will show the indication of where the bad span is in your system. Just for you to be able to visualize it on overhead, and this is marked A, B, and C, you'll notice right here that the overhead fault indicators are detecting faults on the overhead circuit. So it depends a lot on direction of feed. If my substation is on the left-hand side and I'm feeding out this direction, anything beyond the fault indicator that has a fault on it, this will blink. Okay, either individually or all three together, or maybe two together, depending on how many phases have had a fault on it. Alright, fault indicators sense magnetic field caused by current flows through a conductor or cable. Some of them also use a measurement of electrical field caused by voltage in a conductor. The majority are magnetic field type fault indicators. Alright, you got to watch this closely right here because there will be questions on it. Remember, when current flows through a conductor, a magnetic field is created. That's what it's sensing right there, not current. It's not measuring current. It's not an amp meter that we're putting around it, but it does sense the magnetic field given off by high currents. During an electrical fault on a grounded system, additional current flows through a conductor, inducing a magnetic field, which is detected by the fault indicator, causing a state change on the mechanical target flag, which is red and white. LED, they do have blinking types, or remote indication device. The fault indicator measures magnetic field that is produced from high current from faults. Fault indicators do not measure current. They recognize a change in the magnetic field. The indicator has magnets in it that change polarity when a high magnetic field is induced from a fault. You can manually trip or reset a fault indicator with a handheld magnet. Alright, the picture that I have right here, I have a load break elbow, and this is an elbow that you put on primary cable, and then this would go on either H1A or A or B, and the fault indicator is actually built into the elbow. So they do come in this fashion. Typically you don't find them this way. This is very expensive. And you'll notice this is a flag type, and it is showing a fault, red F. This is a clamp-on type, so it's not built into the elbow, and this is a clamp-on blinking light type. Now if you notice right here, you can't just leave it in this fashion inside the transformer open the transformer lid, and if this is blinking red, then you've got a fault on it. Or you can attach a fiber optic cable to it and have this going to the outside of the transformer to where you can see it blinking. Okay, little detail right here, so listen closely. In order for you to install these correctly, now this is either a blinking type or a clamp-on flag type, you'll have to put it in a certain spot and situation on the conductor. So if you have to use it in this situation where it has to go over the jacket and the ground, we have to use what they call neutral canceling, neutral or ground canceling. If you have enough space here above where the neutral is to clamp it on there. It's optimum. You see this black space with no ground on it. But if there is no room because the elbow assembly is coming down too low, you can use it around the jacket and ground, but there has to be neutral canceling. Well, what is neutral canceling? Simply put, if you remember our conductor and our primary cable right here, the primary cable itself has the concentric or ground neutral coming up inside, underneath the jacket. It comes up, comes out. What they have done here is they have folded it back, and now it is going back through the other direction. Still, everything's under the clamp. So think of it in this fashion. If I have 10 amps of current on the neutral, get my mouse back right here. Alright, there we go. If I have 10 amps on the neutral under the jacket coming in, and that same 10 amps is coming back out and through again, I'm going two opposite directions. I'm going inbound and outbound. When that happens, when you do that with a conductor of any type, it cancels itself out. So my amp reading on the neutral is going to be 0, and that's what you need it to be. Go back one right here. Then all the fault indicator, either flag type or light type, then all of the amp reading it's going to get is from the center conductor in here. If I've canceled neutral current in this fashion, everything's under the clamp in two different directions, then the only thing I am now measuring is the current that's on the center conductor inside here. Now you would think, wow, it's got to go through the jacket, the grounds, the insulation, and everything to be able to measure that? Yes, it does. Remember, it's not measuring amperage, it's measuring magnetic field. And the magnetic field given off by a fault in the conductor in the middle can be detected by the fault indicator on the outside. I've attached in this some videos of one is the instructional video and some of the other videos of installations, and got one video here that includes the use and how you're able to use these out in the field, and then a video of a bad transformer with fault indicators also. Alright, the two most commonly used fault indicators. One is the flag type, and that's the one you see on the left hand side, and the one is the fiber optic light type. You will notice right here in the flag type, and this is I would say right now the most commonly used. These are coming up in the world quickly, fiber. But this is the part that clamps around the conductor. You see the gray area back here, and really inside this all there is two magnets. When the magnetic field in here is created from the fault that runs through the gray area, it changes the polarity of the magnets inside the fault indicator, and this will turn to N or F. Now this is showing fault already. So if I had high current here, magnetic field is emanated, induced into the fault indicator, it changes the polarity of the magnets, it will show F. Nice thing about this is it's all one package. It will last forever because it's all mechanical, and all it has in it is two magnets. The one with the fiber optic cable, on the other hand, it does the same thing as the flag one does, but it gives an indication by light. You see the clamp that goes around the conductor? This measures the magnetic field given off by high current. You can just leave this off, this fiber optic cable that's right here on the top of it, and just see a red light blinking. Or you can install this fiber optic cable, mount this light on the outside of the transformer. So this would just be an easy drive-by. If you saw a red blinking light, you know a fault would have been there and you need to progress on to the next transformer in the line. A drawback on these is you have to have a battery to power the light. Now, of course, we're not expecting 300, 400, 500 faults to be on this line and this thing to be blinking all the time. But the recommended life of the lithium-ion battery that's inside here is 7 to 10 years. So you're going to have to revisit all of these locations to change a battery out inside of this to make sure that if you have a fault, it's going to give an indication. This is the only indication it gives. So if I have a fault indicator down here with a dead battery, I might not get an indication. So that's another drawback. Gentlemen, that ends the slideshow. If you've got any questions there, this will go up in the instructional video and in the news. I appreciate all the work that you are doing, and have a good day.